The vapor compression cycle consists of four main components, namely the compressor, the condenser, a metering device, and the evaporator. These components work together to remove heat from one area and then reject it to another using a fluid known as a refrigerant. The compressor pumps high pressure, high temperature refrigerant vapor into the condenser, where it is expelled to the surrounding air, thereby changing the refrigerant from a vapor to liquid state. That change of state is caused by the refrigerant temperature dropping below its vapor saturation point, which is defined as the temperature at which the refrigerant will change from a vapor to a liquid. The heat that has been expelled changes the state of the refrigerant without changing its temperature, and this heat is known as the latent heat of condensation. Any further drop in temperature after the phase change is known as subcooling, which can be defined as the difference between the temperature of the refrigerant leaving the condenser and the saturation temperature of that refrigerant. As that liquid is pumped towards the evaporator, it passes through the metering device, where it expands rapidly, converting it into a low temperature, low pressure liquid, which then absorbs the heat from the area being cooled, giving the cooling effect that the system is designed to create. The heat absorbed from the cabinet raises the refrigerant temperature above its liquid saturation point, thereby converting the low pressure liquid to a low pressure vapor, which then enters the compressor, and the cycle then repeats itself. The change of state that happens inside the evaporator also happens without a change in temperature, and the heat absorbed for the process is known as the latent heat of evaporation. Any temperature increase that occurs after the change of state is known as superheat and can be defined as the difference in temperature between the refrigerant leaving the evaporator and the saturation temperature of that refrigerant. Because the evaporator and condenser serve to move heat from one area to another, they are both commonly referred to as heat exchangers, and the rate of exchange is determined by the medium that heat is being expelled to, as well as the temperature difference between the two. The most common media used in refrigeration systems are air and water. To facilitate this heat exchange, there needs to be a significant difference in temperature between the refrigerant and the surrounding medium, and this temperature difference is controlled by manipulating the pressure in the system.